I made a long way from Singapore and I'm really enjoyed being here. And we're going to talk about security today. So, yeah, this is the security. So what the security is? To simplify things a little bit, let's split the definition of security for a web application into two big groups, which are sanitization and ACLs. Sanitization is primarily a thing that works on the transport level. This is where Rails go in and protect you from things like CSRF, XSS, DOS, or other stuff. On the other hand, we have ACLs. This is the thing that is a part of your business logic. And this is a thing that should be manually controlled by a programmer during software development. And that's exactly what we are going to talk about. That's exactly what we are going to drill in. Internally, ACL contains of 5 steps, which are authentication. That's where we decide who current user is. After that, we try to match his role, doing some kind of authorization. And we understand who the user is and what exactly his role is. The current user and his role is the security context. Just remember this term, we'll use it later. After that, we're trying to understand if current user having this role can access our endpoint. Endpoint in terms of Rails is a controller. After that, we go down and decide if we can access an action. Action in this terminology is something we can do with a model. So if we can destroy it, if we can create it or update it. And as the last stage, we decide if we can make a change, like if we can create a model with a set of particular fields, whether we can modify every of that field or we cannot. When we check all the things, we can now decide if user is applicable of doing what he wants or he doesn't. And how do we typically achieve that? Normally we use a thing called device, right? Who uses device here? Yeah, that's a great tool. That's a great tool, that's why I'm not going to talk about it anymore. Let's just use it. After that go utter accessible or strong parameters for a newer code. So legacy code typically uses utter accessible, and Rails 4 and newer code switch to strong parameters. And the last one, of course, CanCan, which is really a popular thing, and it's amazing indeed. So we start with this set of tools, and things just work basically, right? But then your application starts to grow up. And it grows up and it got tens of roles, hundreds of models, controllers, contexts. It's just getting really huge, and things are getting really complicated to manage. That's exactly what happens inside of that. On the left side, we can see the logical rules that are mainly formed by CanCan. They get to a really huge monolithical block of rules that is really hard to be managed. But in fact, it's quite easy to split something that is monolithical, right? So actually, thank you, CanCan, for being so hassle-free. On the right side, however, we have strong parameters. That in a typical application that uses strong parameters according to tutorial gets splitted and smashed across all the application in small chunks of code in every controller. So if you have a lot of them, you have really problematic way of understanding manually which user can do what. So when a newcomer comes to your new team, ask him if the user A can do B. It's going to take a lot of time to understand if he can do that. So you end up juggling with all that stuff, with controllers, nesting, context, and then other things come up. Then you start using queues. Then you start using nested models in complicated controllers, and it's getting worse and worse and worse. Here's a small example from a real life. We used to make thing I'm talking about when we were working on an online banking software. It had a card model, just a card model. So we had to make it possible to modify card model using it as a nested model of account, of a product, of a widget, and from a sidekick queue. And what's worse, every place where we used card model actually had different security permissions. So it was really painful to manage from CanCan and quite impossible to manage from strong parameters. That's where roots come to play. Most of current web applications are based on data-centric design. So what is that? When we say we want to have slim controllers and we want to have fat models, that's exactly what it is. It's a data-centric design. In fact, Rails is totally based on that. So we want to split things based on what model they belong to and put them exactly to models, or to be concrete to concerns, the term that Rails 4 introduced to us. So what exactly are we going to move to our concerns here? First of all, of course, that a part of CanCan logic that belongs to this model. We'll just take that part and move that to model, like some small module that can be included to common ability file. After that, go strong parameters. And there is one thing that most of strong parameters users don't really understand about strong parameters. Strong parameters are not full stack solution. They don't allow you to control your securities. They're just an interface to protect your model, to actually do protection. So once you pass in the huge hash, allowing to modify one field and revoking your access to other fields, you lose that information. Later, when you try to understand what exactly you want to control, what exactly you want to change, you have no way to do that. So together with strong parameters, you have to have some kind of storage to store all the data and later pass on to strong parameters. That's why in this concern, we also have the presenter. That is a part of functionality that allows us to describe what exactly in model can be managed in what way, and also what can be read. Because strong parameters and CanCan allow us to control what can be changed, but they don't allow us to control what can be read, at least on the level of fields. That's why fields management is a pain. The noble CanCan scales pretty well, but when it comes to field management, we get into real trouble. And to make things work better, we have to implement a lot of stuff on the level of model, not just move the code into them. That's why we keep jungling. We change bolts to pins and keep doing the same thing, but instead of controllers, instead of huge CanCan files, we start juggling with dependencies, models, and duplication. It took a while for us to come with some kind of particular approach that we formed as a gem that I would like to present you today. And this is a protector. So this is a Ruby gem that allows you to do exactly that. It's already domain-specific language that allows you to describe contextual security on the level of your models. So what is a contextual security then? How are we going to decide if the user can actually change or read one field of a model, like our card model? Here we have three fields, title, number, and card holder. We need to decide if we can read number field. We need to find out what's the role of current user is. And we get the security context. And in the cross-section of admin and number, we find out that actual field cannot be read. That's how you do that with Protector. That's a piece of code. Protector adds the dimension of security context into your models. So it extends the way it handles the data and how it tracks the data internally. You just pass it to a class or you just pass it to an instance and your model remembers, okay, I'm working in this context. So instead of just having a card or a set of cards, you have a card of a user or you have a set of cards belonging, not belonging, in context of a user. What's good about Protector is that it tracks your scope down. It tracks your context down. So as long as you have a protected context, a protected scope, everything you get from that, associations, elements of scope, whatever, is already protected and restricted to the same context. So you don't lose security whatever you do. Internally, when you know the context, Protector gives you three magical keywords that help you to manage things and to decide what can be done and what cannot. Those are can, cannot, and scope. Here is a live sample of code we have with a live model, same model card. We have block that is a Ruby code that gets first argument, the security context. And inside of that block, you can define which fields can be read, which fields can be created, used to create a model, which field can be used to update, and if it can be destroyed. It's a Ruby, so you can, whatever meta magic you want, whatever dependencies you want, whatever you want, you just set all that methods, you call that methods, and you define, okay, this can be done and this cannot be done. Like in this sample, for example, we, on the first line, check if current user is an administrator, and if he is, we allow him to read any fields, skipping the second argument to can view. By default, Protector follows the whitelist approach. It means that by default, you cannot read anything. You cannot do anything, which is safer, right? So if you cannot do anything and you define anything, this is safe. So on the first line, we allow our administrators to read any field of cards. On the second line, however, we revoke one field, number. Now they can read anything but the number field. After that, we allow them to create cards containing any fields. We allow them to update cards, but only with two fields, title and number, and we allow them in general to destroy cards. What, however, if we want to bind the card model to a particular user, we want to check if it's a card of a user. Here we use the second argument. We can pass in the instance itself, and we just change one line, and now the same rules apply to a user if he owns this card. So you can combine all this stuff to have all the permissions you want in whatever way you want. What's really cool about Can and Cannot is that they don't destroy your application flow. There are some conventions we use in Rails every day, some of them. For example, validations. We all have our forms and expect validations to happen, right? So instead of throwing some kind of exceptions or just hiding the data and skipping it like strong parameters does sometimes, Protector uses validation. So as long as user tries to do something that he cannot do, Protector will issue a validation thing. So your forms will keep working, and integration of Protector into existing application is an easy thing to do. Here is a little bit deeper example when we have nested models. Can you imagine how painful it is to manage nested hash for strong parameters to control the permissions for something like this? I mean, if you have conditionally allowing of date on the third level, that would be a real pain to construct just such hash. In Protector, what happens in Protector? We get all the models graph defined into Rails in controller. After that, in one transaction, Rails tries to save all that in one step. And as long as at least one model in that graph isn't valid, you get all the transaction rolled back. So things just don't save. And you remember, you have all your security rules split by default by your models. And things just get organized by default. Like I said before, and I want to repeat that, as long as you have something protected with Protector, that look weird, but anyway, as long as you have something restricted with Protector, every association you get from that is automatically restricted to the same context. So you only have to restrict the roots of your graph. Everything you get from that is automatically restricted as well. So you just get a scope, you just have an instance, and every association, everything is restricted as well. It also allows you to use custom rules, like for this thing. This is Alice, and she's supposed to be in Wonderland. And as long as she is in a Wonderland, she can drink anything she wants, and she can eat, but she only can eat a cake. Sorry, Alice. That's how you can define custom things with Protector. You're not bound to things like can view, can destroy, can create. You can create whatever rules you want and any context internally that you want. So that's it, custom rules. And here goes scopes. So we managed to control our field sets. So now I understand how to protect our data on the level of fields. But there is also a level of models where you have to decide what can be selected from database, what can be controlled on another level. Here comes scopes. Like in this example, we make our admins to be able to read any models we can. So when they do like card.all, they get all cards, basically. On the other hand, everybody who's not an admin can only read those cards that are not marked as hidden. So when you do card restrict current user.all, you only get cards that are not hidden. So no matter what happens, no matter how complicated your scope is, if it has joins internally, if it has limits or whatever, Protector makes it best to just limit all the user can read to that scope. What's really exciting about scopes is that no matter how complicated your eager loading is, they always work. It means that if you have two models with totally different restriction scopes, depending on different preconditions, when you eager load them and Rails internally decide, okay, I'll join these models, Protector will create a unified security scope that will apply to both of your models and will limit your data. So no matter how you join your data, if you preload it or if you eager load that, it will always get restricted to whatever you say them. Here is a small final example of how your controller could actually look like in the end. So instead of messing with all underscore params, you just make restrict calls where you want to. An index method extends by restrict, you just make page, and like I said, internally, all the things you get from that scope are restricted, so they're safe. You won't be able to read any field you cannot read. And update, on the other hand, makes pretty the same. It restricts the scope, finds the instance, and calls update attributes. And you can rest assured that nothing that cannot be updated will be. Right now, Protector doesn't only work with active record, it also works with SQL. And we have Mongoid almost done. And when I say almost, I expect it to be done in 1 month or so. So if you use Mongo, you're welcome as well. But Protector wouldn't be so cool without this. Designing Protector we designed Protector as a tool that is supposed to be used in ready-made application. It's not just for those of you who want to start a new application, you want to control the security layers in a new and convenient way. Instead, Protector was designed to be able to introduce to the legacy code. And what we did for that, we didn't want to mess fighting CanCan. I really think CanCan is a great thing. I mean, CanCan rocks. As well as strong parameters if used properly. I mean, the idea is awesome, but they miss some feature that Protector has. So we have bridges between Protector and CanCan. We have bridges between Protector and strong parameters that make them cooperate. And if you have your ready-made huge project using CanCan or based on strong parameters, and you want to introduce Protector in, okay, you just use those gem, and they work together. How exactly it works? When you call can of CanCan, it not only checks the ability file that you have defined, but also it checks the DSL of Protector. So no matter how far away your rule definitions are, it will always seek through all of them. It means that you can evolutionarily migrate your rules from CanCan ability file to Protector to organize them. And you can keep your CanCan usage of actual can calls in place. So you don't have to change things where it's dangerous, because it's security. We don't want to do that, right? You can change your things there where it's safe to keep your code organized with a ready solution. On the other hand, Protector is not just about security. Like I said before, the thing that strong parameters is missing is a metascope, metadata. So once you put something into strong parameters, the data is lost. Things don't work like that with Protector. So if you describe your logic, you can always get the list of fields that you can read, you can always get the list of fields that you can write, and so on. And this is amazing how important this metadata is. Based on that, you can draw a lot of code in your controller. So when we have something working with inherited resources and JBuilder, like, for example, we have a REST server with a Rails backend. Typically, when we have our routes matched the query, we pass to controller that, for example, uses inherited resources. So it's supposed to contain as less code as possible. So if we use JBuilder to build our REST, what stays in the controller unless it does anything but modifying the database? Nothing. As long as we have our security logic defined in our models, we can keep our controllers not just slim, we can make them invisible. Protector has a lot of second-level features that just don't fit the format of the slides. You can check this out on GitHub. I would like to tell a little bit about the future of the project and of the things we're experimenting with and where this is going. Of course, we're going to finish that Mongo thing. That's a real pain for me. And the next thing we're up to do is a data mapper, because for some reasons, like a Phoenix, it's resurrected a little bit time ago with a new name, ROM. And I know guys are working hard to make a release, and we're trying to support it as well, because I think that ORM is amazing. The other thing that we're going to add to Protector maybe in future releases, it's data throttling. So I said in the beginning of this talk that DOS is mostly a transport issue. It's not really true, because there are different kinds of DOS attacks, and some of them might be because of you just put your thighs wrong. Like, if the user would be able to download all the models you have, and there are millions of them, that would quickly let you out of memory and things would go down, right? So with Protector, we are trying to implement some kind of beautiful solution to describe the throttling of data on the model level. It means like, okay, you cannot download more than 1,000 of cards for one set. It makes a lot of sense for REST controllers and different kind of application servers that are developed with Rails as a backend, without having no front end at all. And the last thing, I have heard term PAAS several times on this conference for these 2 days. In my opinion, however, PAAS is something that lets you to start fast doing no backend work when you try to make something, some cute rich application in browser, or you make some kind of a web or a mobile application. And as I said, since Protector gives us ability to keep our controllers really small, I was trying to make a PAAS platform, of course, open source PAAS platform, that would allow you to manage your backend without writing a code, at least in the editor. So it's like you choose what kind of models you want, what kind of fields you want, you describe the structure visually, and you get your backend up and running. On the second stage of this, you get your rules and permissions, because that's a really tricky thing. If you're aware of things like Meteor, did you hear about that? It's a Node.js framework. They have huge problems with security because they have no way to properly describe that. So once we have Protector in Ruby and all the power of this meta magic, we can make a PAAS that would work with Protector primarily. And as a third step, you can go down to Ruby code, download that, and run on Heroku, whatever you want. And I can't believe that, but I did it in 20 minutes like I used to. So, questions? Sure.
So how does a Protector hook into Active Record or in Mongoid, because you're working on it? I mean, what does, how do you actually hook it? I assume that you're using maybe the filters, or if I want myself, to contribute to the project and, make Protector to be supported on other ORMs, what do I have to do?
Oh, it's a great question. I have to say that there was a first version of Protector called Himdall that didn't go outside, didn't go public, because at first we tried to make a proxy surrounding Active Record object, but it just didn't work, because even Caminary didn't work with that. Right now we integrate deeply into Active Record, which internally has a lot of extension points that are not documented at all. So I wouldn't say it's a monkey patching, because actually Active Record itself internally consists of total monkey patching. So we try to use the points of extension that were put into it intentionally, but it's a deep integration. So the only possible answer to that question, GitHub. You can go and see, because that's just impossible to describe in this way. Anything else? Good. Thank you.